Less than 100 years ago, powered flight begins at Kitty Hawk. By 1927, Charles Lindbergh crosses the Atlantic solo in a plane called the Spirit of St. Louis. In 1935, Amelia Earhart is the first person to fly alone from Hawaii to California.
Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind.
During much of the history of aerospace, the United States leads the world in aerospace technology, and aerospace technologies spin off to other key industries: computers, medicine, transportation. Aerospace is a key part of the American economy. Even though U.S. exports of airplanes and space-related products are second only to agricultural exports, most citizens do not fully understand the principles of flight. Increasing our knowledge of science and mathematics would help improve American life and the economy in general. Educators realize children must learn more science and mathematics in order for them to have better lives and to understand today's world of technology. At NASA's Ames Research Center in Silicon Valley, a way to help improve science and mathematics education is devised. Retired Ames director Cy Syvertson proposes a hands-on learning center at Ames for 4th to 6th graders. Syvertson suggests using an old 6-foot by 6-foot supersonic wind tunnel for what is to be known as the Ames Aerospace Encounter. Linda Barrientos and other local teachers work to plan the encounter. The goal is to make it a valuable interactive learning place, a place where students can discover aerospace concepts and realize aerospace is part of science and mathematics. Teachers put much of the encounter together. A teacher's advisory group helps assure methods to be used are effective and fit in with national education reforms. The teachers draw upon the Ames world-class aerospace research facilities for ideas and raw materials. Ames scientists, engineers, and other professionals lend their help. Complete access to cutting-edge support gives an advantage to the encounter which few other facilities have. By November 1991, the Ames Aerospace Encounter is ready for its grand opening. The Aerospace Encounter is designed to enable students to feel, to do, and to see the fundamentals of aerospace, science, mathematics, and physics. In one of 4 main areas, space sciences, children learn about orbital mechanics, the laws of motion, and gyroscopes. Concepts of space physics are taught. Children learn firsthand what is conservation of angular momentum. The children are briefed ahead of time by their teachers about what they are to do and what it could mean. The youngsters learn by playing. Children simulate launching a spacecraft from Earth to Moon. Both heavenly bodies are in motion, and the probe must lead the moon by the proper angle.
We actually spend all that money and go up to the moon and collect rocks. Any idea?
A corps of local volunteer docents make large-scale operation of the Aerospace Encounter possible. Docents come from a variety of backgrounds. A second major activity of the encounter is Space Station. There, student medical specialists take pulse rates and record results. And the youngsters play the role of space station life scientists. Other children work with maps, using coordinates of latitude and longitude. Youngsters work as engineers, mission and communication specialists. A third activity is mission control and remote sensing. Some youngsters communicate with children in the space station module. Other students practice being geology specialists. They use an Apollo glove box when determining rock types. In the Earth observation area, students learn that red represents healthy vegetation as seen on infrared film.
This is an image of the Earth. Their goal is to find mission control at the Ames Research Center, which will be the receiving station for remote sensing images. Can you find some land? Click on the land.
The fourth major activity is aeronautics. A model of a wind tunnel, a facility used to test airplanes and models, is explained.
In a wind tunnel, the plane is actually still. Like this. See how the plane's attached to a pole? You have the air, the plane is still, and the air moves over it. Kind of seems a little backwards, right? Because what do you normally do?
Students learn how computers can aid in aircraft and spacecraft design.
So with this, very quickly, scientists could see how a design would react if it was flying in the air. What we're looking at is something called computational fluid dynamics. It simply means that the computer will solve mathematical equations, so that's why we have computational here. Fluid, because air is a fluid, so it flows over and interacts with the body of the aircraft, and that's what dynamics means.
A panel of teachers and educational specialists continue to plan new educational tools, from curricula and lesson guides for teachers to new interactive displays for the encounter. Not only is the encounter an excellent hands-on learning place for students, it is a test bed for newly developed educational tools. Some educational products developed at the encounter are tested and used in schools. In a Sunnyvale, California school, children and their teachers pass along some of the same principles which they learned at the Aerospace encounter to younger students.
What happened to the water? Why does the water rise?
It's like the moon and the planets. As long as it's spinning on its axis, it will orbit around. If they don't have an axis, and then if they didn't have an axis, they would just fall into space.
Finally, the new science and mathematics teaching resources developed at the encounter are to be distributed nationally. It will be done by word of mouth, by mail, and by computer network. But the real test is how big an influence the encounter can be, and if it can encourage youth to learn about science and engineering.
It actually lifts the wing and it lifts the whole plane.
We see ourselves here at the encounter as an educational conduit for NASA researchers to communicate their ideas in space science and aeronautics to young children. Our job here is to take this information from researchers and put it into a form that children can understand and relate to. I guess you might say that we want children to leave here empowered and real excited by the idea that they can have a stake in the future. That some of the really exciting 21st century jobs on the horizon can be theirs. As a technician, a payload specialist, a scientist involved in a mission in some way. At the Ames Aerospace Encounter, we plant the seed for all that.